Okay, right. Let's start. And can you confirm that you can hear me?
Yes, we can hear you, sir.
Recording in progress.
Okay, thank you very much. In the last week, the last weeks actually, what we were discussing was metal joining, right? Different ways of how to join the metal. So under that, I will go through a little brief. Briefly, right, what we have done in the last weeks. Okay, so in the last weeks, picture 4. Okay, in the fourth lecture, right, we discussed how, and that we have discussed about different welding and these things we have discussed, right? Mechanical joints, how to form mechanical joints, right? These are the things, right? I think you can remember. Then in the second one, in the lecture 5, right, we have discussed about different welding methods. Okay, shielded metal arc welding, gas metal arc welding, right? Those things we have discussed. In the last week also, we have continued that same discussion. Okay, welding methods, additional welding methods, right? You can remember. Okay, these things we have discussed. Okay, so in these uh, in these lectures, right? I told you we are using heat or pressure or both. Okay, අපි සාමාන්‍යයෙන් heat එකයි pressure එකයි දෙකම use කරනවා. Okay, I told you that. But today's lecture, right? Today's lecture, in today's lecture, we are going to discuss about ways we are not using heat, right? We are not going to apply externally, right? We are not going to apply externally. Okay, so there are different ways, right? Different ways of welding without applying heat. Yeah, you can remember. ඔයගොල්ලන්ට මතක ඇති. ගිය සතිවල අපි කතා කරේ heat එක pressure එක apply කරලා weld එක හදන weld එකක් weld කරන විදිහ. අපි දැන් අදින් දැන් කතා කරන්න යන්නේ ඊට වැඩිය වෙනස් දේවල්. right? අපි heat එක දෙන්නේ වෙන වෙන ක්‍රමවලින් කොහොමද weld කරන්න කියලා. Okay? Right. Solid state welding. Welding without melting working pieces. You can remember in the arc welding, right? Shielded metal arc welding, we created spark, right? We created this very extremely hot spark that we could fuse metal pieces together. We could fuse metal pieces, and you could make a bond between those two work pieces. Okay. So we can use, without welding, without melting, you can perform weld. Okay, two clean surfaces brought into atomic contact with each other under different sufficient pressure will form bonds and produce strong joint. Okay, so if you are, if you are providing the sufficient pressure, right, you can form bonds between work pieces. Okay, so that is the thing. Applying external heat, so we are discussing about solid state, right? Applying external heat improves bond by diffusion. Okay, so if you can introduce external heat, you can improve the connection, but it's an additional. Okay, you can improve by external heat, but without applying external heat, you can form bonds. Okay, so these are some of the solid state welding methods: ultrasonic welding, friction welding, and resistance welding. We will list each of solid state welding types. Okay, I will use most of the videos, right? Since you can gain more understanding on how these welding methods are working on. Okay, මම ගොඩක් videos වගේ දේවල් පාවිච්චි කරනවා ඔයගොල්ලන්ට හොඳට idea එක ඔලුවට එන්න. Okay? Cold well, right? Pressure pieces by through work. So you can apply using dice or force, right? So for this one, right? First of all, if you apply considerable force on bond between the work pieces, right? අපිට මොකද pieces දෙකක් අරගෙන ඒ දෙකට sufficient force එකක් A4 එකකින් ඒ pieces දෙක, that is the wall value. Uses plastic deformation, right? I can't remember whether I have explained to you about plastic deformation. මම ඔයගොල්ලන්ට plastic deformation ගැන කියලා දුන්නා. I can't remember whether I have explained to you about plastic deformation. Did I explain to you what do you mean by plastic deformation? අනික් මොඩියුල් වලත් කියලා. I think there is a signal issue, right? Signal issue since it's a holiday, therefore I have some small signal issue. That's why, right? You cannot hear me. Okay? දැන් ඇහෙනවද කියන එක? Can you hear me? තාම කැඩි කැඩිද ඇහෙන්නේ? තාම තාම කැඩි කැඩීමද ඇහෙන්නේ?
Brother is clear.
ඈ? Sorry. Okay, right. හිටපු ගමන් ඇහෙන්නේ නේ. එහෙම කියන්නේ ඇහුන් නැති වුණොත් ඔයගොල්ලෝ මේ hand raise කරන්න මම bye කියලා දෙන්න. Okay? I think there is a small signal issue. That's why. Okay. The question I asked was whether I have explained you about this plastic deformation. මම මේ plastic deformation එක ගැන ඔයගොල්ලන්ට කියලා දුන්නා. I think I haven't explained to you about plastic deformation. Okay? Right. Right. There is a graph called stress strain curve. Graph එකක් තියෙනවා. Stress strain curve. Right? There is a graph called stress strain curve. Right? This is the stress. Strain. Okay? So can you remember what do you mean by stress? Stress කියලා කියන්නේ මොකක්ද කියලා ඔයගොල්ලෝට මතකද? මට කියන්න බලන්න. Can you tell me what do you mean by stress? What do you mean by stress? Can you remember what do you mean by stress? Can you tell me what do you mean by stress? I think I can remember I explained you about stress, right? So can you tell me what do you mean by stress? Stress කියලා කියන්නේ මොකක්ද? මතකද ඔයගොල්ලෝ? Right? Stress mean, let's say we have some kind of we have some kind of mm, right? I will use this one. Okay. Right? Let's say we have some kind of we apply forces in two directions. Okay. We apply forces in two directions. Right? We apply forces in two directions. So what will happen? There will be a stress generated within the cross section of this body. Okay? මෙන්න මේ විදිහට ඇදපුවම මෙන්න මේ අතරේ stress එකක් හැදෙනවා. Right? ඒක ඇති වෙන්නේ force එක නිසා. Right? So due to the apply force, there will be a stress acting within the body. Right? So that is called the stress. Strain mean it is called elongation. Strain කියලා කියන්නේ elongation. කොච්චර ප්‍රමාණයකින් දිග වෙනස් වුණා. ඒක තමයි strain කියලා කියන්නේ. Okay? There is an equation for strain. I'm not going to use that equation, right? It's E divided by L, but I'm not going to use that one. Okay? So elongation is a measure about how much it has extended. Right? මේක මෙහෙම ඇදපුවා මොකද මේක දිග වෙනස් වෙනවනේ. Right? අන්න ඒකේ measurement එකක් තමයි මෙන්න මේ strain කියලා කියන්නේ. Okay? So if you plot the graph, okay? If you plot the graph, what will happen? It will be like this, right? මෙන්න මේ වගේ curve එකක් තමයි N. ඒක regions දෙකක් තියෙනවා. Right? There are two regions in the curve. Okay? So this is called elastic region. This is called elastic region. This is called plastic region. Okay? These are the two terms. Okay? I will use two colors, right? This is the elastic region. මේකට අපි කියනවා elastic region එක කියලා. Now, and this is called plastic region. You will learn about this strain curve under strength of material or properties of material, right? ඔයගොල්ලෝ ඉගෙන ගනි මේ stress strain curve ගැන, strength of material නැත්නම් properties of material කියන subject එක. Okay? You will learn, right? But this is a simple summary. And if you don't understand, don't worry, right? If you don't understand, don't worry. Okay? Right. So what is the difference between these two elastic region and plastic region? මොකද්ද මේ elastic region එකේ plastic region එකේ තියෙන වෙනස? What is the difference? Okay? ඔගොල්ලෝ දන්නවනේ, right? You know that. So let's say you have a piece of rubber, right? You have a piece of rubber. ඔගොල්ලෝ ගාව තියෙනවා rubber piece එකක්. Okay? If you apply force, okay, ඔගොල්ලෝ ඒ rubber piece එකට දෙපැත්තට ඇද්දොත්, right? If you apply force, මොකද්ද කියන්නේ බානුක මොකද්ද වහන්න මොකද්ද මට ඒක තේරෙන්නේ. කැඩෙන තැන, right? That කැඩෙන තැන, this one, right? This is called breaking, right? In here, right? If you apply sufficient force, it will, it will be broken. Okay? Then again, a breaking point. Some are again failure point. There are different types, right? Point of failure, point of break, right? At that point, it will be broken. Okay? Then තමයි කැඩෙන්නේ. So what I asked was what is the difference between elastic region and plastic region? Okay, so elastic region, right? Let's say we have a piece of rubber. අපි හිතමු මොකක් හරි rubber piece එකක් තියෙනවා කියලා, right? If you pull apart and if you remove the force, it will come back to its previous position, right? අපි rubber piece එකක් වගේ එකක් අරගෙන ඒක දෙපැත්තට දාලා ඇද්දපුවම, right? එහෙම කරලා අතෑරපුවා මොකද වෙන්නේ? අර තිබ්බ original position එකටම එනවා. Okay, right. So that is the elastic region of the rubber piece. Okay, and there is a point called yield point, right? There is a point called yield point, right? Yield point කියලා point එකක් තියෙනවා. අන්න එතනින් පස්සේ, right? After beyond that yield point, you cannot gain the original position, right? ඒ yield point කියන එකෙන් පස්සේ අපි force එකක් කියන්නේ force එකක් දීලා අතෑරියට කලින් තිබ්බ position එකට එන්නේ නැහැ, right? So that region is called plastic region, right? If you achieve plastic region, you cannot achieve the previous dimensions of the body, right? මොකක් හරි object එකට force එකක් දීලා අතෑරියට අර කලින් තිබ්බ shape එකට කලින් තිබ්බ dimension වලට එන්නේ නැහැ, right? So that is called the plastic region. Okay, so we are using this plastic region or this plastic deformation to perform the welding. Okay, did you understand? මම කියලා දුන්න එක තේරුණා? Did you understand? Okay, right? I think you got it. Okay, so we are using okay, right? I think you got it. So we are using this property. We are using this property, this plastic deformation property, in the cold welding process. Right? අපි plastic deformation වලදී use කරන්නේ මේ cold welding වලදී use කරන්නේ plastic deformation කියන process එක. Hence requires metal to be ductile, right? So you can remember what do you mean by ductility, right? I think explain to you what do you mean by ductility. The ability to undergo plastic deformation, right? Ductility කියලා කියන්නේ plastic deform වෙන්න පුළුවන් හැකියාව. Okay, so that is called the ductility, right? So this curve, right? This curve is relevant to what type of material? Ductile material. Okay, මේ curve එක අදාළ වෙන්නේ ductile materials වලට විතරයි, right? Ductility ගොඩක් තියෙන materials වලට විතරයි. එතකොට brittle material එක තිබුණොත් මොනවා එකක් දෙන්නේ? මෙන්න මේ part එක, මෙන්න මේ plastic region එකක් ඒකේ නැහැ. තිබුණත් ඒක ගොඩක් පොඩියට තියෙනවා. එතකොට okay නැහැ. Okay, so that is for brittle material. Ductile material, what are the examples for ductile materials? What are the examples for ductile material? Right, most of the metals. Okay, ගොඩක් metal වර්ග අයිති වෙන්නේ ductile වලට. මොකද metals වලට පුළුවන් plastic deform වෙන්න. එතකොට වීදුරු, right? වීදුරු, chalk ඒ වගේ දේවල් ductile නෙමෙයි. ඒවා නිකම්ම කැඩෙනවා. ඒවා brittle material. Okay? Prior to welding, surfaces should be clean proper. අපි සාමාන්‍යයෙන් weld කරන්න කලින් හොඳට surface එක හොඳට clean වෙනවා, right? The surfaces should be clean. Otherwise, I mean, we try to make a atomic bombs, right? Therefore, you will not be able to gain good bond between two surfaces other if you are not clean those surfaces properly. Okay, when the two materials are similar, bond is strong, right? එකම වර්ගයේ material, right? Copper, iron, right? Likewise, if the two materials are similar, the strength of the bond is very strong. Okay, so up to now, did you understand? ඔයගොල්ලන්ට ඒ වෙනකන් කියලා දෙන්න එක තේරෙනවා? Okay, right? I think you got it. Right. Okay. So this is the cold welding process, right? An example, roll bond, right? So in the roll bonding, you can see from this diagram, right? So we have the main material, the base metal. Right? This is the main material. This one. This is the main material. Okay. We are using an additional material, cladding material, right? You can consider that one as additional material. So by using rollers, what we can do? You can apply sufficient force to make a bond between these base metal and cladding metal. Okay. අර ඔගොල්ලෝ මතකයිනේ plastic deformation ගැන කතා කරා. එතකොට මෙතනදී වෙන්නේ plastic deformation එක. මොකද වෙන්නේ? අපිට ඕන කරන අපි ගොඩාක් ලොකු force එකක් දුන්නම මොකද වෙන්නේ? මේ base metal එකයි cladding metal එකයි plastic deform වෙලා bond එකක් හැදෙනවා. Okay. When the cold welding pressure is applied to rollers, it is called roll bond, right? Since we are using rollers. අපි rollers use කරන නිසා මොකද වෙන්නේ? මෙන්න මේ base metal එකයි cladding metal එකයි එකට එකතු වෙනවා. Okay. So I will show you an example how to do this roll bonding, but in this video, we are I mean it does not show metal, right? මෙතන අපි metal එකක් නෙමෙයි පේන්නේ. I think it's some kind of plastic material, but you can I mean this is the process, right? මේ ඒකේ වෙන දේ මෙන්න මේකයි උනට එතනදී මට මතු විදිහට metal එකක් නෙමෙයි use, right? But let's see anyway. Okay. Okay, right. I think you saw that. Okay. So here there are two thin films, right, which are not metals. Okay. මෙයා ලෝහ නෙවෙයි ඒ වුණාට වෙන්නේ මේ ඒ ලෝහ දෙකක් එකට මේ materials දෙකක් එකට එකතු වෙන එක. Okay. මෙන්න මෙයාගේ එකතු වෙන එක. Rollers, these are the rollers. Okay. You can see these are the this is the roller 1 and this is the roller 2, right? By using these rollers you can fix or you can make an attachment between two work pieces. Okay. So did you understand? මෙතනට නිකන් කියලා දෙන්න එක තේරුණා. Right? Did you understand? Did you understand about this roll bonding? Okay, right? You got it. Okay. Right. The second thing is ultrasonic welding, right? So we are discussing about these four things, right? These cold state welding methods, right? Ultrasonic welding, right? අපි ඊළඟ කතා කරන්නේ ultrasonic welding. Right. So surfaces are subjected to normal force and oscillating shear stress, right? අපි මෙතනදී වෙන්නේ මොකද්ද වෙන්නේ? There are two work pieces, right? There are two work pieces. Okay. There are two work pieces like this. There are two work pieces like this. This is and this. Right? This work and this is the workpiece 2. Okay. We apply forces right in this direction and we vibrate the workpieces. ඔගොල්ලන්ට තේරෙනවද කියලා? මේක තමයි workpiece 1. Right? This is the workpiece 1 and this is the workpiece 2. We apply forces in these two directions. මෙන්න මේ දෙපැත්තෙන් forces දෙකක් දෙනවා. Right? These are in contact, right? මම මෙතන මේ gap එකක් දාලා ඇඳුනට මේ දෙක එකට ගෑවිලා තියෙනවා, right? මේ දෙක එකට ගෑවිලා තියෙනවා. Right? These two work pieces are in contact and we vibrate, right? We give some oscillation, right? අපි දෝලනය නැත්නම් vibration එකක් දෙනවා. මෙන්න මේ work piece දෙකට. එතකොට මොකද වෙන්නේ? මේ දෙක ඇතිල් වෙනවා. Right? These two they are up against each other or they are vibrate each other. Right? මෙන්න මේ දෙක මේ work piece දෙක එකට ඇතිල්. Right? ඔගොල්ලෝගේ අත් දෙක අරගෙන ඇතුල් වෙන්නේ අන්න ඒ වගේ ඇතිල් වෙනවා. Then what will happen? Right? ඔගොල්ලෝ අත් දෙක මෙහෙම මේ දිගට අතුල්ලද්දි මොකද වෙන්නේ? heat එකක් හැදෙනවා දැනෙනවනේ. Right? So same principle is there. Due to that generated heat, what will happen? There will be a chemical bond between the gap. Right? මෙන්න මේ වගේ මේ දෙක අතර chemical bond එකක්. නැත්නම් bond එකක් හැදෙනවා. Right? So that is called the ultrasonic welding. Okay? ඒ කියලා දෙනක තේරෙනවා. Did you understand? That is the principle behind ultrasonic welding. ඒක තමයි ultrasonic welding එකේදී වෙන්නේ. Did you understand? Right? So we apply a normal force and oscillating shear stress. Right? Shear stress means you could remember, right? Parallel to the surfaces. Right? Surface එකට parallel වෙන විදිහට දෙනවා oscillation. Right? Oscillation. The frequency of oscillation is usually in the range 10 kilohertz to 75 10,000 kilohertz to 75 kilohertz. එතන මේ රත් වීමකුත් වෙනවා. ඊට අමතරව ඒකිනුත් හැදෙනවා, right? ඒ surface එක clear වෙලා bond එකක් හැදෙනවා. Shear stress causes plastic deformation and breakups oxide films on the surface, right? So due to that rubbing, right? Due to that rubbing, what will happen? The surface become plastically deformed. ඒ ඇතිල්ලීම නිසා. මොකද වෙන්නේ? අර මම කලින් කිව්ව මෙන්න මේ plastic deformation එක. This one, and this one happens. So due to that plastic deformation, what will happen? Break up the oxide films on the interface, right? Usually metals have oxide film or oxide layer on the outside of the workpiece. Therefore, due to that shear stress or due to that vibration, that layer become damaged or that layer will be removed. Okay. Temperature is usually half or 1/3 of the melting point, right? temperature එතනදී හැදෙන heat එක නිසා හැදෙන නැත්නම් එතනදී හැදෙන temperature එක මේ metal එකේ melting point එකෙන් භාගයක් හරි තුනෙන් එකක් හරි, right? So that is one of the main advantages, right? You can make the uh, make the bond with low temperature, right? Relatively less than the melting point of the workpiece, right? So that is an advantage you can see. Okay, so I will show you how this ultrasonic welding is done. This is an animation. Okay, මේකද මෙන්න මේ අවසානයේ කියලා කිව්වේ මෙන්න මේ temperature is usually half or one third of a melting point කියන එකද? Okay, right? So usually, right, you can remember in the fusion you have to melt the workpiece, right? ඔයගොල්ලෝ මතක ඇතිනේ මොකක්ද මේ fusion welding වලදී අපි workpiece එක melt කරා. ඒ වුණාට මෙන්න මේ ultrasonic welding වල තියෙන advantage එක තමයි මෙන්න මේ මේ melting point එකෙන් භාගයකදී නැත්තම් තුනෙන් එකදී, right? Let's say melting point is 900, right? 900 Celsius. Okay, so by using this ultrasonic welding you can perform the weld at 300 degrees Celsius or 450 Celsius. Okay, within these low temperatures, right? Due to that rubbing, these surfaces become those surfaces will achieve these temperature, right? මෙන්න මේ temperature එක achieve කරගන්න, right? ඒක නිසා මේකේ bond එක හැදෙනවා. තේරුණා නේද? අහලා තිබුණේ කවුද? බානු, right? Did you understand? හරි නේද? අඩු temperature එකකදී ඒක හැදෙනවා. Right? So usually these types of ultrasonic weld I have experience in mostly in wires, right? Wires මෙන්න මේ ultrasonic weld use කරා, right? මෙන්න මෙයාගේ ultrasonic weld වලින් අපිට පුළුවන් සමහර wires වල connection එක හදාගන්න, right? Let's say we have one right? එකෙන් ඇවිල්ලා තියෙනවා. හරිද? මේ එනෝද සිග්නල් ඉෂුව එකක් මම හිතන්නේ තියෙනවා. right? එනෝ නේද කියන එක? පොඩි සිග්නල් එකක් තියෙනවා, right? Okay, right? I think you can hear. Okay, so let's say there are two wires දෙකක් තියෙනවා කියලා හිතන්නකො. මෙන්න මෙයාගේ wires දෙකක්. අපිට පුළුවන් මෙන්න මේකට ultrasonic weld එක මෙන්න use කරගෙන මේ wire එකේ bond එකක් හදන්න. මේ දෙක connect කරන්න. Okay, so there are some ultrasonic welding apparatus, right? Especially in the electronic manufacturing. සාමාන්‍යයෙන් ultrasonic welding මෙන්න මෙයාගේ use කරන electronic manufacturing වලදී, right? මෙන්න මෙයාගේ wires දෙකක් connect කරන්න. එතකොට ඒකෙන් ඔයගොල්ලෝ ඇත්තටම ඇහෙනවා ඒකේ සද්දේ අර කීංගාල නිකන් සද්දයක් වගේ ඇහෙනවා. ඒක මේ අහන් ඉන්න හොඳ නැහැ. ඔයගොල්ලෝ සාමාන්‍ය use කරන කට්ටිය කන් දෙක වහගෙන තමයි ඒක කරන්නේ. Okay? Right. So I will show you how this ultrasonic welding is done. Okay? Sound working. I will use ultrasonic this one.
In cars, wiring harnesses transport signals and electric. In cars, wiring harnesses transport signals and electric current. Up to 6 kilometers of cable can be installed in a modern vehicle. They ensure that the car starts, that the headlights work, and that tyre pressure is displayed on the onboard computer. The connections among these innumerable cables must be perfect in order to function perfectly over the entire lifetime of the car. For this reason, ultrasonic metal welding is the method of choice for fixed and durable cable connections. The energy required to connect metals is achieved with extremely fast vibration, ultrasonic frequencies. Schunk is the global market and technology leader in ultrasonic metal welding. Here, an innovative process is used to fuse metallic materials through high-frequency mechanical oscillation. The advantages: the joints exhibit excellent electrical properties, the connection is fixed and durable, and process control during welding is perfect. One application example is wiring harnesses.
Then next is friction welding, right? Before I explain to you about this friction welding, I know how this is done, right? මම දැන් friction welding ගැන කියලා දෙන්න කලින් මම පෙන්නනවා ඔයගොල්ලෝ මේ friction welding කියන්නේ මොකක්ද කියලා, right? Okay.
How does inertia welding work? Basically, by forcing together pieces to be joined in such a way that rotary motion and pressure are converted into heat, which literally bonds the pieces into one part. Two pieces to be joined are aligned in an inertia welding machine. One piece is held stationary, the other is rotated rapidly on a spindle chuck attached to a flywheel. When the flywheel reaches a predetermined speed, it is disengaged and the freewheeling piece is forced against the stationary piece. Friction between the parts heats the budding surfaces to forging temperature. Just before rotation ceases, the two pieces bond automatically. When the flywheel stops, the weld is complete.
Okay, right? So that is the friction welding, the third topic we are going to discuss. Okay. So you saw that what we are going to do in the friction welding. මොකද්ද friction welding කරන්නේ? Okay. So we have two work pieces. Friction welding වලදී work pieces දෙකක් තියෙනවා. Right? Work pieces. Okay. This one and this one. Okay. මෙන්න මේ වගේ work pieces දෙකක් තියෙනවා. This is the first work piece. This is the second work piece. Okay. So what we are going to do? We try to rotate one work piece. අපි එක work piece එකක් අරගෙන කරකවනවා. Then after that, what we try to do? We bring these two work pieces in. අපි work pieces දෙක ඊට පස්සේ ගාව. Right? I mean, these similar to that ultrasonic welding, right? These surfaces are also subjected to rubbing, right? මේ දෙක stationary තියලා අනික කරකවනදී මොකද වෙන්නේ? මේ දෙක rub වෙනවා. ඇතිල් වෙනවා. From that, it will create a heat, right? ඔයගොල්ලෝ දැක්කනේ මෙන්න මෙතනදී, okay? මෙන්න මෙතනදී දැක්කනේ මෙන්න මේගේ
Attached to a
right? You can
pieces
see that
surfaces to forging.
it will create an enormous heat which will melt the work pieces. මෙන්න මේ work piece දෙක melt වෙන තරම් ලොකු heat එකක් හැදෙනවා. Right? From that you can make a bond. Okay, so that is the friction welding. Right? So did you understand about what do you mean by friction welding? Friction welding කියලා කියන්නේ මොකක්ද කියලා තේරෙනවද මොකක්ද? Did you understand? Yes, right. You understood what you mean by friction welding. So this is the graph of variation of speed, force, and upset length. Right? You can see a change in length of the workpieces. අපි මේ දෙක, right? Yeah, we use lathe machine, right? You can, but I don't think it will provide sufficient speed, right? ඒක melt වෙන්න තරම් ලොකු speed එකක් හදන්න පුළුවන් වේද? මේක ගොඩක් මේකේ speed එක ඇත්තටම සෑහෙන ලොකුයි, right? මේකේ බලන්න ගොඩක් ලොකු speed එකක් අරගෙනවා.
To a flywheel predetermined speed, it is
It has, the rotation speed is very high, right?
discouraged against the stationary piece.
In the
Friction
lathe machine, I'm not sure, but it's possible, right? I'm not sure about it, right? It's a good way of thinking, right? ඒක හිතපේ ගොඩක් වටිනවා. Okay? ඒක සමහරට පුළුවන් වෙන්නත් පුළුවන්. Okay? මම පොඩ්ඩක් ඒක ගැන හොයලා බලන්න. Okay? Right. But I don't think sufficient I don't think the speed is not enough, right? මම හිතන විදිහට මෙතන මේ speed එක අපිට ඕන කරන තරම් නැති වෙන්න පුළුවන්. Okay? lathe machine එකෙන් හදන්න තරම්. Okay, so this is, as I said, this is the variation of the speed, force, and offset length. Okay, so this is how they vary, right? So, අපි සාමාන්‍යයෙන් when මේ process එකේදී speed එකයි force එකයි length එකයි වෙනස් වෙන විදිහ තමයි මෙතන තියෙන්නේ. Okay, the part on the left is rotated at high speed, right? In the left part, right? In this situation is the left part, right? මෙතනදී කරකෙන්නේ left එක. Left is rotated at high speed. The part on the right is brought in contact under an axial force. Axial force එකක් use කරලා අනිත් piece එක ළඟට ගේන්න. The axial force is increased and the part on the left stop rotating. Flash begins to form. Okay, so due to that generated heat, there will be a flash, right? Flash means by deforming the workpiece, it will create some kind of profile, right? මෙන්න මේ වගේ profile එකක් හැදෙනවා. Okay? මෙන්න මේ වගේ ගොල්ලන්ට පේනවා. Right? It will create a profile like this. මෙන්න මේ වගේ file එකක් හැදෙනවා, right? මෙන්න මේ වගේ. ඒකට අපි කියනවා it is called flash. After specify upset length or distance is achieved, the welding is completed, right? අපි දැන් මේක ගෑවිගෙන යද්දි මොකද වෙන්නේ? මේ work piece වල length එක අඩු වෙනවා, right? work piece එක length එක අඩු වෙනවා. එහෙම අඩු වෙලා එක අපිට ඕන කරන level එකට ආපුවම අපේ weld කරන එක නතර කරනවා, right? So that is the upset length. Okay, upset length, distance the workpiece move inward during the welding, right? The length is it's reducing. Okay, after some point we stop rotating. Okay, so that friction welding, right? So when you perform this friction welding, there are some problems, right? One of the problem is this profile, right? The flash profile. The weld zone size depend on force applying speed, rotation speed, and the rotation speed of the workpiece. මෙන්න මේ flash කියලා කියන්නේ මෙන්න මේ additional කියන්නේ එළියට එන part, right? This entire zone is called the weld zone. මෙන්න මේ සම්පූර්ණ part එකට අපි කියනවා weld zone කියලා. Right? So you can see the profile of the flash or the weld zone. මෙන්න මේ වගේ weld zone එකේ නැත්තම් හැදෙන flash වල shape එක මෙන්න මේ වගේ අපිට බලා ගන්න පුළුවන්. Right? So if you apply high pressure and low speed, you will gain this profile. If the pressure is low and the speed is high, you will gain this profile. If you maintain proper pressure and speed, you will get this profile. Okay, so this is the best one. මේක තමයි හොඳ මේක. Force supplying speed and rotation speed of the workpiece, amount of heat generated, right? Due to the amount of the amount of heat generated will have an impact size of the weld. thermal conductivity of the material, right? Thermal conductivity කියලා කියන්නේ it's a measure of how I mean the ability to conduct heat from the material. Mechanical properties of the materials at the elevated temperature. එතකොට මේ work piece එකේ temperature එක වැඩි වුණාම ඒකේ තියෙන ඒකේ material properties නැත්නම් mechanical properties වල හැසිරී ඒව මත තමයි මෙන්න මේ weld zone එක depend වෙන්නේ. Right? Did you understand? කියලා දුන්න එක තේරෙනවද? ඒ කියලා දුන්න එක තේරෙනවද ඔයගොල්ලන්ට? ඒ කියලා දුන්න එක තේරෙනවද friction welding ගැන? Did you understand that one this friction welding කියලා දුන්න එක තේරෙනව නේද ඔයගොල්ලන්ට? Once again means what do you want to know? කොයි එකද දැනගන්න ඕනේ? මේ part එකද? Okay, right. So I told you that we are maintaining this speed force, mainly speed and force, right? අපි කියවනේ මෙන්න මෙයාගේ speed එකයි force එකයි අපි maintain කරගන්නවා කියලා හරි විදිහට, right? මම කියන්නේ කාවින්දට, right? අපි මෙන්න මේ විදිහට speed එකයි force එකයි හරි ගන්නට maintain කරගන්න ඕන. එතකොට force එකයි speed එකයි හරි ගන්නට තිබුණ නැති වුණොත් මෙන්න මේ profile දෙක හැදෙනවා. Right? If you are not maintaining proper force and the speed, you will gain profiles like this. මෙන්න මෙයාගේ profiles දෙක තමයි හැදෙන්නේ. In the profile layer, you can see high pressure or high force and low speed. You will gain this profile. And if you maintain low pressure or low axial force and high speed, you will gain this profile. And if you maintain proper speed and pressure, you will gain this is the best one, right? This is the optimal profile. Okay, so now you understand. Then තේරෙනවද කියලා? Okay, right? So the additional thing I have told you is this weld zone depend on these parameters. Okay, the applied force, right? I told you that you have to maintain proper force and speed. Apart from that, you will need the zone depends on these factors, right? Amount of heat generated, thermal conductivity, and mechanical properties of the material. Okay, so those are the things I wanted to tell you. Then the next one is friction stir welding. ඊළඟට කතා කරන්නේ friction stir welding ගැන. I think I have included the video. I think after that we will see.
From building bridges to erecting skyscrapers to assembling airplanes and cars, welding allows engineers and manufacturers to connect metal structures. But the method of joining metal to metal through melting had remained mostly the same for decades. That is, until 1991, when a new kind of welding was invented. Instead of melting metals to connect them using high temperatures, this new method, called friction stir welding, uses friction, just like when you rub your hands together on a cold day to warm them.
Friction is everywhere, and if friction did not exist, we will not have a comfortable life. We are able to walk on any surface because we have friction that allows us to walk.
Rajiv Mishra, a professor at the University of North Texas, is one of the world's foremost experts on Though Mishra didn't invent friction stir welding, he's using his imagination, a key component of the innovation process, to create new applications of this technology. In his lab at the Center for Friction Stir Processing, which receives funding from the National Science Foundation, Mishra demonstrates how friction stir welding works. He begins by taking 2 aluminum alloy plates clamped together tightly in a machine. A metal tool resembling a drill bit is inserted in between the plates. The tool spins as it travels along both edges. The friction created by the spinning tool heats the atoms in the solid metal, making them move around or diffuse. The metals become deformed, and atoms from both plates are bonded together without any melting.
Friction between the tool and the workpiece creates the heat, which then allows the material to become softer and become more plastic. And so the plasticized material then moves around.
In a matter of minutes, the aluminum plates have been welded together and are cool enough to touch. The bond created by friction perfectly smooth and as strong as the original aluminum plates. When he first observed how friction stir welding changed the microstructure of the metals, Mishra started imagining new ways that it could be used for more than just welding.
So the idea behind that is that instead of taking many pieces of metal and then bonding it together, you can take a single piece of metal and give it a complex shape. If you look at cars, back lid of cars, if you look at aircraft doors and so on, we can change the strength of material, we can change fracture toughness.
Mishra started using the friction stir welding tool to strengthen the microstructure in more complicated metal parts that are usually cast from molds, like the rim of a car wheel.
This is a region which experiences high stress, and it is sensitive to fatigue. And so we could friction stir process the region to show that our strength and fatigue properties are much better in this region.
No one had ever attempted to use friction stir processing except as a tool to bond 2 pieces of metal together. Mishra's innovative way of using it to make metal stronger ultimately led to 4 patents granted by the U.S. Patent and Trademark Office.
When we took friction stir process, the process already was invented, it existed. It was just that it was being applied in one particular way, and we thought of other ways.
Through extensive testing, Mishra and his students continue to learn all they can about how the friction stir process transforms the physical and mechanical properties of all sorts of metals. Mishra hopes he can convince more designers and manufacturers that advances in friction stir processing can one day make cars, planes, and trains lighter and stronger.
Okay, so that is friction stir welding. Okay, so you have an idea how this friction stir welding is working. Okay, so there is this non-consumable tool rotating. Okay, you have this non-consumable rotating tool, and it will be rotate, right? Make a caracal. From that you can rub, right? You can rub 2 work pieces together by using this tool, and it will create a heat. From that heat, these 2 work pieces are fused together. මෙන්න මෙයාගේ කැරගෙන tool එකක්, right? Non-consumable means it's not going to wear up. Okay, from that you can by using friction you can make these 2 work pieces bonded together. Okay, so that is the friction stir welding. Friction stir welding by using non-consumable tool, which is rotated and plunged into interface of 2 work pieces. The tool is then moved through the interface, and friction heat causes the material to heat and soften. Okay, so we are going to move this non-consumable tool here and there, right? අපිට ඕන කරන direction වලට මෙන්න මේ tool එක කරකවන ගමන් යවන්න පුළුවන්. Aluminium alloy plates up to 75 millimeter thickness have been welded by using this process, right? You can use a softer metals like aluminium or aluminium alloys. Used for aerospace alloys, right? You can use it for aerospace alloy, and in the video you saw that in the automobile applications also we have used friction stir welding. low heat input, low distortion, right? So this will create very very low heat, okay? Making hadena heat එක ගොඩක් අඩුයි, right? Compared with that those fusion welding method, right? අපේ fusion welding method වලින් use කරන වලදී හැදෙන heat එකට වැඩිය ගොඩක් අඩු heat එකක් තමයි හැදෙන්නේ. Components must be ductile when hot to perform deformation, right? Usually we can the material should be ductile. Okay, for ductile materials, you can do this friction welding. Okay, right. Okay, so I think we have completed these three out of these three out of these four. We have completed up to third one, right? Friction welding. The next thing is resistance welding. අපි ඊළඟට කතා කරන්නේ resistance welding ගැන. Okay. Resistance welding. Okay. So the principle behind resistance welding is you know that ඔගොල්ලෝ කරලා ඇති. Right? ඔගොල්ලෝ experience ඇති, right? You may have an experience. If you have a battery and if you connect the positive edge and negative edge, you will feel some kind of temperature in the wire, right? අපි බැටරි එකට මෙන්න මෙයාගේ වයර් එකක් අරගෙන මෙන්න මෙහෙම ගහුවොත් ඔයගොල්ලන්ට දැනෙයි මෙන්න මේ වයර් එක රත් වෙනවා. right? ඔයගොල්ලෝ දැනෙනවා මේ වයර් එක රත් වෙනවා, right? That is because due to the resistance, right? Mainly the resistance, it will create some kind of heat. මෙන්න මේ වයර් එකේ තියෙන resistance එක නිසා heat එකක් හැදෙනවා. Okay, so that heat can be calculated by you can say Q, right? Heat Q. Q equals I squared R. Q equals I squared R, right? I means the current flowing within the wire, right? This current. R is the resistance. Okay, R is the resistance. Okay, so this is the equation you can apply to this is the amount of heat, right? This is the amount of heat. This is the equation you can use to calculate the amount of heat generated within within this wire. Okay, so there is another equation called V squared divided by R. V is the potential difference, so the voltage, right? Voltage of the currents of the battery. Let's say battery. Okay, V squared over R over I squared R. Okay, so due to that, the reason for generation of heat is the resistance of the material within the wire, right? මේ wire එකේ තියෙන resistance එක නැත්නම් මේ wire එක අදලා තියෙන material එකේ තියෙන resistance එක ඉඳන් තමයි heat එකක් හැදෙන්නේ. So you can use the same principle in the resistance spot welding. Okay, spot welding, also known as resistive spot welding, is a resistance welding process. ඔගොල්ලෝ දැකලා ඇති spot welding. Okay, මම ඒකත් පෙන්නලා ඉන්නම් ඔයගොල්ලන්ට.
A resistance spot welder is designed to deliver a low voltage, high current electrical pulse. The weld electrodes are made of copper because copper has a low resistance to current flow, which allows it to conduct electricity with ease. Steel is a very poor conductor of electricity, and it will resist the weld current as it flows from the spot welder. The friction created by the current forcing its way through the metal heats the weld area to over 2000 degrees Fahrenheit. The squeeze pressure from the weld electrodes now compresses the molten area and fuses the two metal surfaces into one solid nugget. By maintaining the squeeze pressure for a short time after the weld current is shut off, which is known as hold time, the molecules in the welded material remain compressed as the weld cools. This additional pressure results in a much stronger weld. Electricity in your shop, how it works, and why you need to understand how it affects the performance of your welders and other equipment. Single phase. This is how the electricity is delivered from the electric company. When viewed in an oscilloscope, you can see the current as a sine wave form that alternates between positive and negative polarity across the zero line. This form of electricity is called alternating current, or AC. The frequency of the wave cycles is always consistent, and it is measured in cycles per second, or hertz. 1 hertz is one complete wave of current starting at zero, moving up to the maximum or peak level, falling down through zero, and then up again from the negative peak to the zero line again. Let's look up close at one sine wave. The AC current waveform alternates through the zero line from positive to negative. At 3 different times in one cycle, the power is zero as the current completes the cycle. This means that there are inherent losses involved in AC power. The losses result in inefficient use of available power, and when used with resistant spot welding, the weld quality is negatively affected. As you can see in the slow motion graphic of this spot weld, there is an irregular, pulsating 60 Hz delivery of current.
Get 3-phase power from the electric company if you want to use better welder technology for better welds. The entire waveform starts out as a single cycle, but it is followed by a second sine wave delivered 120 degrees after the first one, and a third sine wave is started 120 degrees after the second one. Remember, AC current has 1 sine wave per cycle, but 3-phase current has 3 sine waves per cycle during the same period of time. With 3 times the sine waves, the 3-phase current is much better than single phase. However, the 3-phase sine waves still alternate through zero, resulting in losses. To isolate the 3 phases and make the current more efficient, it can be directed through a device called a diode. A diode allows current to flow through it in only one direction. If a group of 4 diodes is arranged as a bridge and the AC voltage is connected across it, a bumpy but totally positive polarity ripple results. The process is called rectification, and the output that comes from this process is called direct current, or DC. The DC wave is much smoother than the non-rectified wave. This results in less loss and makes the 3-phase DC current better for welding than single-phase AC.
Both the 208 voltage 60 Hz standard in the United States and the 400 volt 50 Hz standard in Europe and Asia have
Okay, so that is
limitations
about
when they are
that is
used to
about
run high-powered
the different voltages used in spot welding, right? What I wanted to show you was this one. Okay, so by using 2 electrodes, you can supply current, and due to the resistance of the material, what will happen? It will create heat, right? It will generate some amount of heat. From that, these 2 work pieces, they melt, they become molten. Okay, so that is the resistance spot welding. This welding process is used primarily for welding 2 or more metal sheets together by applying pressure and heat from electric current to the weld area. When we electrodes they use right? By using these 2 electrodes, what you can do? You can actually provide current, and also you can provide pressure. ගොල්ලන්ට පුළුවන් මේ electrode එක use කරලා, right? By using this electrode, right, you can provide current and also you can provide pressure. From that, it will form a bond between these 2 work pieces. Okay, it works by contacting copper alloy electrodes to sheet surfaces, whereby pressure and electric current are applied, and heat is generated by the passage of current through the resistive materials such as low carbon steel. Okay, so usually the material, right, the workpiece has a high resistance to flow current. Okay, මෙන්න මේ දැන් අපි මෙන්න මේ low carbon steel වගේ දේවල් වල නැත්නම් ඒ වලින් හදපු work pieces වල current එක යනවා, කියන්නේ current එක යන්න තියෙන resistance එක වැඩි, right? current එකට යන්න තියෙන බාධාව වැඩි. Therefore, due to that resistance, okay, you can remember the equation. Okay, you can remember the equation I squared R. Okay, so if you increase the resistance, the amount of heat generated within the within this material is high. Therefore, it will form atomic bond due to that applied heat. Okay, so we are usually using this extremely high current, right? අපි මේ වගේ තැන්වලදී use කරන current එක ගොඩක් වැඩි, right? It's from 3000 ampere to 5000 ampere, but the voltage is very low, right? Around this range, right? 5 to 12 volts. Current එක වැඩි, voltage එක අඩු. හරි නේද? So that is the principle behind resistance spot welding. Okay, මෙතනට නිකන් කියලා දුන්න එක තේරුණා. Or else, do you have any questions? Now we have a resistance spot welding machine in our faculty. So we can do a practical on by this resistance spot welding. Okay. Faculty එට ඇවිල්ලා තියෙන මේ resistance spot welding machine එක. එතකොට අපිට පුළුවන් practical එකක් කරලා බලන්න. කොහොමද මේ resistance spot welding එක වැඩ කරන්නේ කියලා. Okay. මෙතන නිකන් ප්‍රශ්න මොනවද තියෙන්නේ? තේරෙන දෙයක් තියෙනවද මොකක්ද? තේරෙන දෙයක් හරි ප්‍රශ්න මොකක් හරි තියෙනවා නම් කියන්න. Do you have any questions? Do you have any questions? මොනවද තියෙනවද ප්‍රශ්න? තේරුණාද කියලා දුන්නේ? එතන මේ ඔතන මේ මම අහලා තියෙනවා ස්පොට් වෙල්ඩින් කරද්දී අතින් අල්ලනකොට මේ කරන්ට් එකට යනවද කියලා ඇඟ හරහා. එතන කරන්ට් එක යන්නේ නැහැ. මට මතක විදිහට හේතුව මෙන්න මේ වෝල්ටේජ් එක අඩු නිසා, right? මෙන්න මේ අඩු වෝල්ටේජ් එකක් තියෙන හින්දා, right? මෙන්න මේ අඩු වෝල්ටේජ් එකක් තියෙන හින්දා ඒක ඇඟ හරහා යන්නේ නැහැ. Okay? මේ කියන්නේ අඩු වෝල්ටේජ් එකක් කරන්ට් එක යන්න වෝල්ටේජ් ඩිෆරන්ස් එකක් තියෙන්න ඕනේ. මෙන්න මෙයාගේ අඩු ඩිෆරන්ස් එකක් තිබුණම ඒක ඇඟ හරහා යන්නේ නැහැ. ඒක පුළුවන් තරම් යන්න බලන්න මෙන්න මේ වර්ක් පීස් එක හරහා. Right. Okay, so මම ඒක පෙන්නනම් මේ මෙන්න මෙතන තියෙනවා මේජ් එකකුත් අතින් අල්ලගෙන මේ තියෙන්නේ. මෙන්න මේක අපිට පුළුවන් අතින් අල්ලගෙන කරන්න. ඇඟ හරහා කරන්ට් එක යන්නේ නැහැ. Okay?
Recording stopped. Recording in progress.
I think there was a small connection issue. Sorry about that. Okay. Okay. So this is what I wanted to tell you, right? මම මේ ගැන තමයි කියන්න ගත්තේ. Okay. So these are the steps of resistive spot welding. At first, what we are going to do is applying pressure. අපි මේ work piece එක මත මේ electrodes වලින් pressure එකක් දෙනවා. Then we turn on the current. අපි current එක on කරනවා. Current off, pressure on, right? While maintaining the pressure, we turn off the current. අපි pressure එක දෙන ගමන් current එක off කරනවා. Then after that, you can release the pressure, and here you will observe that the two metal pieces are welded together. ඒ දෙක weld වෙලා කියලා ඔයගොල්ලන්ට පේනවා. Okay, so at that point you can after releasing the pressure, you can see that these two pieces are bonded together. Okay, So you can see the cross section, right? There will be a weld nugget, right? This shape of මෙන්න මේ shape එක තියෙන විදිහට තමයි melt වෙලා තියෙන්නේ, right? It is called a weld nugget. Okay, so that is the cross section. If you observe the cross section of the weld workpiece, okay, right. Then there are different arrangements. Okay, there are different arrangements so that we can fit two workpieces in a different direction, right? මෙන්න මේ වගේ arrangements තියෙනවා electrode arrangement, right? By using this electrode arrangement, you can make two workpieces bond together. මෙන්න මේ වගේ workpiece electrode arrangement වලින් අපිට පුළුවන් දැන් workpiece තියෙන එක එක shapes වලටනේ, right? Workpieces are in different shapes, right? So sometimes you may not be able to fit your workpiece into your machine. Therefore, there are different configurations so that you can fit your workpieces into the machine. Okay, so these are two of the arrangements. Okay, two types of electrode designs or configurations for easy access to spot welding operation for complex shapes. Okay, so that is the arrangement. Okay, but in those two arrangements, same thing is done, right? මෙන්න මේ arrangement දෙකේම වෙන්නේ එකම දේ. ඒ වුණාට arrangement දෙක. I think I have shown. Okay. Then the next thing is resistance seam welding. Okay, it's similar to this resistance spot welding. Under resistance spot welding, you observed that we were able to perform welding on a single spot. That's why we call resistance spot. Okay, අපිට ඔයගොල්ලෝ දැක්කනේ එක point එක spot එක විතරයි ඔයගොල්ලන්ට weld එක කරන්න පුළුවන්කම තිබුණේ. So let's say if you want to do it continuously, right? අපිට හිතන්නකෝ continuously කරන්න ඕනේ කියලා. අන්න ඒ වගේ තැන් වලට අපි use කරනවා resistance seam welding, right? We are using resistance seam welding at that point. Okay, so instead of electrodes under resistance seam welding, we have wheel shape electrodes or electrode wheels. අපි කලින් දැක්කනේ මෙන්න මේ වගේ දෙකක් තිබුණේ spot weld. Electrode resistance seam තියෙන්නේ electrode wheel. We have given the current into these wheels. මෙන්න මේ wheels වලට තමයි අපි current එක supply කරන්නේ. And we roll these wheels so that workpiece will be moving along with the rollers. From that you can perform the weld. Okay, ඒ rollers දෙක කරකවන ගමන් workpiece එක යවලා අර spot welding එකේ වෙන දෙයම තමයි ඒ වෙන දෙයම කරන්න පුළුවන්. Okay, so is a illustration of seam welding. Seam එක කියලා කියන්නේ මෙන්න මේ වගේ එකක්, right? මෙන්න මේ තියෙන්නේ ඇඳුම් වලත් seam අල්ලනවා කියලා කියන්නේ ඇඳුම් වල හැම තියෙන අර බ්‍රෙදි කෑලි දෙකකට ඇතිල් මේ මහන තැන වගේ, right? So that is called a seam. Illustration of seam welding process with rollers acting as the electrode, right? අර මේ spot welding වල වගේ නෙවෙයි එක දිගට කරන්න ඕන අපිට මේ වගේ seam එකක් ඕන. Overlapping spot on the seam welding, right? I think it's beam, right? Overlapping spot අර දිගටම මෙන්න මේ වගේ weld එක කරගෙන යන්න පුළුවන්. Cross section of the rolls spot welding, right? This is the cross section, right? මෙන්න මේ වගේ තමයි cross section එක තියෙන්නේ. This is okay. Then mesh seam welding. Okay, so you can use there is additional way of supplying heat by using induction. මෙන්න මේ වගේ අපිට පුළුවන් induction coil එකක් use කරලා additional heat එකක් දෙන්න, right? I will show you in the video this one. Okay, by using an induction coil එකක් use කරලා මෙන්න මේ විදිහට heat එක දෙන්න පුළුවන් as a support for this resistance seam weld. Okay, okay, so that is the resistance seam welding. So you can see these are the rolls, right? මෙන්න මේ තමයි rolls. These are the rollers. And this one. And this one, there is an additional one on the top as well, right, in this example. Okay. So that is the resistance seam welding. And you can see that you can use a coolant, okay, to reduce the heat. Okay. Okay. So in the resistance seam welding also, we are using high current, low voltage. අපි resistance spot welding වල වගේම තමයි. Similar to resistance spot welding, we are using high current and low voltage. Mesh seam welding involves rapid production of continuous weld seam by means of overlapping resistance spot welding, right? So we can අර මම කිව්ව කලින් කිව්ව කතාව එක දිගටම කරගෙන යන්න පුළුවන්. Okay? So you can see that same example. Okay. Then the next one is resistance projection welding, right? The next one is resistance projection welding. Under this resistance projection welding, we are using a sheet containing this kind of projection, right? My projections. Okay, these are the projections. A high electrical resistance at the joint is developed by embossing one or more projection in the surface to be wet, right? By we are making these kind of projection. When we have projections use karna ape resistance projection welding well. High localized temperatures at the projection. Then what we going to do is we supply current into these electrodes. Due to that current, what will happen? Similar to that previous resistance welding methods, okay, it will create heat and it will generate heat to make workpieces bond together. Okay. The main difference is this one, right? When we have projections, okay. So from that projections, you can get you can the change in the shape, it will create high resistance. Okay, can be used to melt sheets, metal sheets, right? You can use this method to weld nut and bolts to metal sheets, right? But in most of the situations, we have more experience in these spot welding. මේ වගේ තමයි ගොඩක් වෙලාට use වෙන්නේ. Okay. Then the next one is flush welding. These are still resistance welding methods, right? මේ තාම අපි කතා කරන්නේ resistance welding method ගැනම තමයි. Okay? අපි කතා කරන්නේ resistance welding method ගැනම තමයි. Okay? Flush welding I will show you what